Hello again. Hope you're all safe and well, as always. This is the video to accompany the Factbook section on ionic bonding. That is, as I understand it, Year 9 combined course. This is week 3, so the week commencing 22nd of June, lesson 1. For the Year 9 triple, it is week 3 also, a week commencing 22nd of June, lesson 1. And for the Year 10 combined group, that is the second lesson of week 2. So this accompanies the facts for your second lesson of the week commencing the 15th of June. Okay, as the title suggests, we're going to look at some of the key facts you need to be aware of to do with ionic bonding. These are the ones in your fact book. So the fact that all bonding involves the outer shell electrons only. We're going to look at ionic bonding in particular, how the ions form, how we can show this with diagrams, why this holds the compounds together, and we're going to look at some of the key properties of ionic compounds as well. So to start with, we'll just there are some questions you can have a go at, so if you want to pause the video and have a go at these, we will go through them in a moment. So I'm just going to click through the slides, then I will go through the answers, but obviously as you watch the video you can pause it and have a go at each question individually. So there is question 1, based on the information on the screen. Question 2. Question 3. Question 4. And question 5. Okay, so we'll go back through those and just go through the answers. So question 1, which element has the electronic structure 281? Well, it's going to be in the first column because it has one electron in its outer shell, so it's in group 1. It's going to be in the third row down because it has 3 shells. So we've got hydrogen, lithium, sodium. So the correct answer for that one is sodium. Sodium is in the third row down, 1, 2, 3. And it's in the first column, so it has 2 in its first shell, 8 in the second shell, 1 in the third shell. Second question, which one is a positive charge? Well, positive begins with P, proton begins with P. That's how you were told to remember it in the previous videos. A proton has a positive charge. Hopefully you all got that correct. Atoms of different elements combine to form new compounds. If they have combined chemically, they form compounds. So the answer to that one is D. Number 4, when two substances share electrons, the substances will bond. That is one of the ways that two substances can bond, is by sharing electrons. And the last one, which of these is an ion? Well, an ion is an atom or group of atoms that has become charged. And the only one there with a charge is N3 negative. So the answer is B, N3 negative. Okay, right, so different types of bonding. We're going to look at ionic bonding in this video. Is always between a metal and a non-metal. If the two atoms involved are metal, one is a metal and one is a non-metal, it is ionic bonding. Covalent bonding is between non-metal atoms, we'll get to that in a future video. Metallic bonding, as the name suggests, is between metal atoms. Again, we'll cover that in a video yet to come. All bonding, regardless of what type it is, involves electrons, and it involves changes in the number of electrons in the outer shells of atoms. So, looking at ionic bonding, this involves atoms becoming what we call ions. Now, an ion is an atom that has gained a charge. It has become charged, either positively or negatively. To become charged, an atom needs to either lose or gain electrons. Remember, when it is an atom, it has the same number of protons and electrons, same number of positives and negatives, therefore overall it has no charge. If it gains or loses electrons, it then has an unbalanced number of positives and negatives, so it will either become positively or negatively charged, depending on whether it has gained or lost electrons. So, most atoms have incomplete outer shells. That means they are unstable. What they want to do is they want to end up with a full outer shell, either by filling in a gap or gaps in their outer shell to fill it up, or by losing spare electrons from their outer shell to end up with the next shell in as the outer shell. Okay? Whenever that happens, they will then have an unequal number of protons and electrons, which gives the atom a charge, and it becomes what we call an ion. So, when an atom loses electrons, that means it loses negative charges. It will end up with more protons than electrons, more positives than negatives, so overall it will have a positive charge. It becomes what we call a positive ion. When an atom gains electrons, it will then have more electrons than protons, and that means overall it will have a negative charge because it has more negative charges than positives. It will then become what we call a negative ion. Okay? If an atom has a nearly empty outer shell, the easiest thing for it to do is to lose electrons. So it loses the spare electrons from its outer shell if it only has a small number of them. If it has a nearly full outer shell, and it has only maybe one, two or three gaps in its outer shell, the easiest thing for it to do is gain electrons to fill up its outer shell. Okay, so metal atoms always lose electrons because they tend to be in groups 1, 2 and 3 in the periodic table. They only have 1, 2 or 3 electrons in their outer shell. The easiest thing for them to do is lose those electrons to end up with a full outer shell, because they've lost the free ones from their outer shell. So they always form positive ions because they always lose electrons. Okay? When something becomes an ion, it then has a charge symbol next to it, and quite often it will have a number. That tells you how many electrons it has lost or gained. If it is a positive, then the number next to the positive tells you how many electrons it has lost. So for example, lithium has 1 electron in its outer shell, so when it loses that electron it becomes lithium 1 positive. Because there's no number there, because it is just 1 positive, it tells you it has lost 1 electron. Magnesium has 2 electrons in its outer shell, so when it loses them it becomes Mg2 positive. Because it is 2 positive, that is telling you it has lost 2 electrons. Aluminium has 3, so when it loses those it becomes Al3 positive. The 3 positive part tells you it has lost 3 negative charges, 3 electrons lost. Okay, so again, looking at these, we can see from each of the electron arrangements or electron configurations, this one has 2 electrons in its outer shell, calcium, so it is going to form a 2 positive ion because it will lose those 2 electrons and therefore become positive by 2. Hydrogen only has 1 electron. If it loses that, it becomes 1 positive. Phosphorus, fluorine and beryllium, they are non-metals. We'll come to those in a moment. Sorry, phosphorus and fluorine are non-metals. Beryllium is also a metal. It has 2 electrons in its outer shell. If it loses those 2, it becomes 2 positive. Okay, there is a video link you can use to give you a bit more information on that. Now, when an ionic bond is formed, as we've said, the metal atom will always lose electrons. So in this case we have sodium and we have chlorine. Sodium is the metal, chlorine is the non-metal. Sodium has 1 free electron in its outer shell. Chlorine has 7 electrons in its outer shell. That means it has 1 space. So the easiest thing for it to do is to gain an electron to fill up its outer shell. So sodium wants to lose this electron, chlorine needs to gain an electron. So sodium loses an electron to chlorine, and that fills up chlorine's outer shell. So what you end up with is a sodium ion, which now only has 2 shells, because it's lost this free electron from its outer shell, and it has a charge of 1 positive, because it's lost 1 electron. You also then have a chlorine ion, which has now filled up its outer shell, so there's the electronic gain from sodium to fill up its outer shell. Because it has gained that negative charge, it has become an ion with a charge of 1 negative. Now this is what's called a dot and cross diagram. That's mentioned in the Factbook. Okay, and it's called that because you represent the electrons in one atom as dots and the other one as crosses, and what that does is it lets you identify and show where the electrons have been lost and gained. So in this case, sodium's electrons are crosses. You can see that one there has ended up in chlorine's outer shell, because chlorine's electrons are represented by dots, and that's the cross, that's the electronic gain from sodium. Often in exams you'll only be shown the outer shells, you won't necessarily be shown all the shells inside, you'll just be shown the outer shells to work with, but the principle's the same. Okay, it can also be shown like that, so sodium goes from being 281, 1 electron in its outer shell, and chlorine 287, 7 electrons in its outer shell. When the ionic bond forms, sodium then becomes 28, because it's lost this free electron. Chlorine becomes 288, because it has gained that electron from sodium to fill up its outer shell, so it now has 8. Now, ionic bonding then is what happens as a result of this change, this transfer of electrons. Okay, because some of them become positive, because the metal ions become positive and the non-metal ions become negative, there is an attraction between the positive metal ions and the negative non-metal ions. We know opposites attract, so the positives are attracted to the negatives. That's what we call an electrostatic attraction. And these electrostatic attractions between the positive and negative ions, they are what we call ionic bonding. They are the ionic bonds. That is what holds the substance together. So in the case of sodium and chlorine, because the sodium atoms become positive ions and the chlorine atoms become negative ions, they are attracted to each other, and that holds the compound together, that electrostatic attraction between the positive and negatives. Okay. So showing it again, exactly the same idea. Sodium has 1 electron in its outer shell, it loses that and becomes 1 positive. Chlorine has space for 1 electron in its outer shell, because it's got 7, so it gains that electron from sodium, there it is, and it becomes negative. And then the bond is formed between the two of those, it is the attraction between the positive and negatively charged ions. Okay, now that is a very strong attraction, and that gives ionic compounds certain, that gives them certain properties. Okay, now they form what we call ionic lattices, because the attractions between them are fairly uniform. They form what's called a lattice, which is a repeating structure. Okay, so what you get is positive and negative ions held in a set structure. That's why ionic substances often form crystals. So they're held, each of them held together by an ionic bond, this attraction between the positive and the negative, in what we call a lattice structure. So that would be an example of sodium and chlorine, held together in a lattice. There's the positive sodium ions and the negative chlorine ions. Now that gives them certain properties, okay, because they are arranged in a regular way. The ionic bonding gives them certain properties. So ionic compounds, as a result of these strong ionic bonds between the ions, they have very high melting and boiling points. Because ionic bonds are very strong, because these attractions between the positives and the negatives are very strong, that gives them very high melting and boiling points, because it takes a lot of energy to break these ionic bonds and split the ions up into liquids and gases. Likewise, they conduct electricity, but only when they have either been melted, or when they are molten, or if they have been dissolved in water, because that's the only time their ions can move. When they're a solid, the ions can't move, so they cannot conduct electrical charge. When they are dissolved or melted, the ions can move, and so they can carry electrical charge, and they can conduct electricity. Okay. The other key point is that they dissolve in water, because water itself, a water molecule, has a slightly positive and a slightly negative end, and therefore it can attract and pull apart the positive and negative ions in an ionic compound. So ionic compounds have high melting and boiling points, they dissolve in water, and when they are dissolved in water, or if they have been melted, they are able to conduct electricity, because at that point their ions can move. When they're a solid, their ions are fixed in a lattice, so they cannot move. Okay, so there's the facts again. I hope that's been of some help to you. Thank you.